Okay, hope everybody's having a good day. I've only got a couple of problems that I want to go ahead and show you to kind of wrap up the lesson. One of them is even going to be a problem off of the assignment. So this guy right here, this is going to be due on Tuesday. Remember, you have a 3-day weekend. Now tomorrow when you come in, we will have a focus activity, which shouldn't take too long. I'm thinking maybe 5 minutes, and then I'm planning on just giving you the rest of the time to work on your assignment. So you probably even could finish it before you take off for the 3-day weekend. But you probably want to do math over the 3-day weekend, so we'll see how that works out. So yesterday, I started to show you problems where you could substitute part of the equation using an identity. And that allowed us to use one of the previous techniques, maybe factoring or some kind of algebra in order to use it. And we finished yesterday with these problems that are manipulating x or theta inside. Now you solve the problems exactly as you normally would. So pretend that this one just said sine of x equals 1/2. Okay. Well, what I'm looking for are all the answers between 0 and 2 pi, right? So let me get my unit circle here. Okay. So let me erase all this. So the problem I'm looking for is sine of 1/3 x is equal to 1/2. X over 3, that's 1/3 x. So don't worry about the fact that I'm doing anything to x or theta. Save that for the very, very last. That is the last thing you're going to work on. Pretend it just said sine of x equals 1/2 like our other equations. So what am I looking for specifically? How do I know where my answers are going to be? What am I looking for? There you go. Remember, sine is y, bless you. So I'm looking for every y value, every coordinate that has a y value of a positive 1/2. Well, I see one right here, so I'm going to start with pi over 6. Then what? We've got 5 pi over 6, and those are going to be the only two, right? Okay. Now, what I'm going to go ahead and do is say x equals, and I'll go ahead and write these a little bit differently so we have some room here. So x equals pi over 6, or x equals 5 pi over 6. Okay. Now for a normal equation, we would be done, but this is where that last part now comes in. Remember, it's not just x, it's 1/3 x. Okay. So now I want to go ahead and solve for x with this little equation that I created. Does that make sense? Okay. Well, I could go ahead and divide through by 1/3, but it's probably going to be better if I just go ahead and multiply both sides by 3. Okay. Because what's 3 and 1/3 going to do to each other? They're going to cancel. So there's x is equal to, now this would be 3 pi over 6, but that's pi over 2. Okay. Now I'm going to do the same thing for the other one. So those are going to cancel. So x is equal to, so 5 pi over 6 times 3, what would that be? 15 pi over 6. Not until you simplify. That's correct. So if you're just multiplying by a whole number, yes, it's like you're multiplying it by 1. That's exactly right. Okay. And what is 15/6 going to become? 5 pi over 2. Okay. So here are my two possible answers, right? Now, the only other thing we want to make sure of is we know what area am I looking at. Remember, the problem said I want to go ahead and look on the interval 0 less than or equal to x, which is less than 2 pi. Okay. But I'm not using x. Remember, I divided it by 3. So that means I need to divide the others by 3 as well. So what's 0 divided by 3? Well, that's 0. Less than or equal to x over 3, less than 2 pi over 3, that won't reduce, right? So see, I can no longer go the full revolution. I can only go to 2 pi over 3. I have to stop right here. So for example, is pi over 2 in that range? Yeah, so pi over 2 is an answer, right? Okay. But 5 pi over 2, I would have to go all the way around and then back through. Is that in the interval? Now see, it's outside the interval, so while it's still correct, it's not on the one I'm looking for. Okay. So if this were a problem, like say on a quiz or maybe even a test next week, I did put a couple of these on there. If you were to go ahead and give me 5 pi over 2, I wouldn't count it wrong. But remember, some of these questions are going to be multiple choice. In fact, pretty much like 80–90% of them are multiple choice, and then I gave you just a few free response. Okay, so how's that? We're good? All right. So let's try one more of these. Okay. We saw one yesterday. I think some people were having a little bit of a issue with it. So let's do another one. In fact, let's do one off the homework now. So let me take this off real quick because I'm going to need that. Oh, do I need to put it back? There we go. Okay. So let's work number 5. Number 5 on your homework is very similar to this one. You are manipulating theta. Okay. Is everybody ready? All right. So let's see here. We're going to go ahead and work number 5. I believe it's going to be right here. There we go. And here's what you're going to do on your homework assignment. I'm going to have you take off 8 problems because there's some of these that they got a little more advanced than what we had the time to talk about, so I'm not going to worry. So you don't have to work numbers 7 through 12. You can just slash those out. And you don't have to work numbers 24 or 26. Okay. So that only leaves you 18 problems, and we're about to do one together here. We can do some problems together tomorrow, so it's not a lot. Okay. You don't have to work numbers 7 through 12, 24, or 26. Okay. Well, let's take a look at what number 5 says. It says cosine of 2 theta equals -1/2. Okay. So it's already simplified for cosine equals, right? The only difference here is that it's 2 theta. Well, forget that for a second. Just go with the fact, where would I find cosine of theta equals -1/2? Okay. So this time I'm looking for an x value that's a -1/2. Where am I looking? Okay, so I heard 2 pi over 3. Here's a x that's -1/2, so that's what I'm going to start with. Then the other one is 4 pi over 3. There's the other -1/2. Now remember, if this problem had just said cosine of x equals -1/2, we'd be done. We have our 2 answers. Okay, but here's where the change is. If I come back over here, I would say theta equals 2 pi over 3, and theta equals 4 pi over 3, but it's not theta, it says 2 theta. Okay. So you set that expression equal to the answers we would normally get. Well, how can I go ahead and get rid of the 2 now? Yeah, divide through. But since I have fractions, maybe it'd be easier to go ahead and multiply through by the reciprocal times 1/2. Squeeze that in there. Okay. So let's see, those 2's are going to cancel. So theta is equal to, this would be 2 pi over 6, which is equal to what? Okay, 1/3 pi. So that is pi over 3. There we go. Okay. Now the other one, again, the 1/2 and the 2 are going to cancel. So there's my theta equals, but 4/3 pi, bless you, times 1/2, that's going to be 4 pi over 6. So what's that one? Okay, 2 pi over 3. Okay. So is everybody okay with how I'm just making that one little change at the end for whatever they may be doing to theta or x? Okay. Now let's look on my interval. Okay, what interval am I looking at to find these answers? Okay, now remember, at the top of the page, it says we want to go between 0 and 2 pi, right? We'll just apply the change you see in your problem. Now, even though I'm using theta, I'll change it to theta, why not? Okay. So I want 2 theta, not theta. So I'm just going to multiply this by 2. So that means I got to multiply 0 by 2. And I've got to multiply 2 pi times 2 as well. Okay. So what's 2 times 0? 0. Less than or equal to 2 theta, which is less than 4 pi. So now I'm not looking in just one revolution, I'm looking in two positive revolutions. Okay. So let's see here. The first answer we got was pi over 3, right? So I'm going to come back over here. So if I start rotating counterclockwise, okay, what was the first one? I completely forgot. Pi over 3 and 2 pi over 3. I started going to 2 pi over 3. So pi over 3, I'm going to go ahead and rotate to here. Is that between 0 and 4 pi? Yes. So that is an answer. Now the next one was 2 pi over 3, right? So if I rotate here, is 2 pi over 3 between 0 and 4 pi? Yes. Okay. Now we saw one like this yesterday. If I'm going to continue to go around, like there's one revolution, and then there's a second revolution. What's the key word I'm thinking of as I revolve again? Starts with a C. That's going to help me get my other answers. Coterminal. Okay, that's right. Because, see, I could go ahead and continue to revolve these around, but then I need to go around one additional time. So for this one, pi over 3 was an answer, but now I'm going to come all the way back around to pi over 3 again. So what am I actually adding to pi over 3? Yeah, another full revolution is 2 pi. Remember, that's coterminal. I go all the way back around and stop there. Okay. Well, what's a common denominator? It would be 3, right? So this is going to be pi over 3 plus 6 pi over 3. So 7 pi over 3 is also an answer because it's within 2 full revolutions. Okay. Now, how do you think I'm going to find that other answer using 2 pi over 3? Yeah. So like this one here, if I started revolving around and got to 2/3 pi, well, then I want to go all the way back around again to the exact same location. So I'm going to do the same thing. I'm going to take 2 pi over 3, and I'm going to add 2 pi. Is this making sense? Okay. Is everybody okay with that? Okay. So let's see. That would be 8 pi over 3. That's exactly right. Okay. Because I multiply by 3 over 3, 2 pi over 3 plus 6 pi over 3. That is 8 pi over 3. Okay, so you just want to be a little careful on those problems that say like 2x, 1/2 x, anything like that. It will change that interval you're looking at. If it shrinks it, that works out nicely. If it doesn't, you're probably looking at coterminal angles. Everybody okay? Okay. And then you'll notice the one right next to it, number 6, is the exact same way. Okay. You're taking half of theta. All right, but maybe that's one we want to go ahead and take a look at tomorrow, but those are all my answers. Okay, so that's all I have. The only other thing we have today is just the quiz, and that's it. So I'll tell you, the quiz will not have any of those problems. They're just your normal standard problems, maybe some factoring, isolating the term, nothing fancy. Okay. Yes, ma'am. Yeah, you want to go real quick and then we'll get started? Yes, ma'am.
Never mind.
Never mind. Okay, if you do remember your question, let me know.